Welcome to all. It is part 1, lecture 6. This you can see in the title only and thumbnail also. Remember, we already applied law of parallelogram forces for some simple cases. Now time has come to understand or know very important concepts for application of law of parallelogram forces. One by one I will tell. You should make a note and see some of the statements in the class. I will dictate. As I told earlier, you have to write it. So in the class I will dictate. Only in the notes I will write all those things. See, first one by one. This I will remove, not required. This everybody will knowing this one. Okay. First one. Remember, there are two forces here. See whether forces are this way or this way or this way or this way or even this way and this way, more angle. These all does not matter. We want two forces passing through a point. Angle is theta. See, I write here. P1 and P2 are two concurrent forces passing through a point. Passing through a point. I will do one thing to save the time. Say O. Say O, making an angle theta between them. Okay. So here, see, you can make a note. You can call LE1 P1, any other P2. There is no restriction. See, if you want, you can call this as P2, this as P1, this as P1, this as P2, this as P1, this as P2, anything. See, theta, 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 or one more. See, theta, one of them P1, one of them P2. Now you have to observe something. Make a note. See, if theta is less than 90 degrees, theta 90 degrees is a special case, I won't discuss. Less than 90 degrees. Then, see, I simple language, I will write one force this way, but one important, both the forces should be either acting away from the point or acting towards the point. Yesterday I told what to do. Or simple language, both should be either outgoing or incoming. This I am telling 100 times, I think. Now see, now this angle is less than 90. See, this angle theta is less than 90 degrees. Then which is P1, which is P2 is not required. That is not important for us. Now, how resultant will come? See here, when you consider parallelogram of forces, see one side here, this force here, complete the parallelogram, this is a point, this is the resultant. See, therefore, resultant will come this way. I will mark here only. Resultant, not horizontal, in between. Resultant R. If it is less than 90 degrees, it will come in between. It will be closer to this force or closer to this force depending upon the magnitude of the force. If the two forces are equal, then resultant will bisect the angle. Suppose theta is 80 degrees. If both the forces are equal, resultant will make 40 degree each. Suppose imagine, for an understanding, make a note this way. Say 80 degrees. One force P1 I will call, one force P2. If P1 equal to P2, resultant will make 40 degree here, 40 degree here. Suppose P1 is more than P2, then resultant will be more near to P1. Why? Which is the higher force, resultant will shift that side. Then, see, this angle here will be what? So I will write here, see, if P1 is more than P2, then see, P1, P2, I will do one thing, P1 more I told, so bigger I will write. P1. Resultant will be this way. Surely this angle will be less than 40 degrees. This angle will be more than 40 degrees. Now, how much lesser you can't tell. If P1 is very, very high compared to P2, it can come even 10 degree also, 5 degree also, or even 0.1 degree also possible. Or suppose P2 is more than P1. You should write everything. That is what, see, sorry, this is actually, P1, correct. I told P1 here, P2 here. Suppose P2 is more than P1. You don't bother which is P1, P2. See, P1, P2, bigger. Angle is same, 80 degree only. Take 80 degrees. Then same, if theta is 80 degrees, resultant will be near to P2 then. This will be less than 40 because near to this one, this angle will be more than 40 degrees. Or right, resultant will shift that side, or it will go near to that force which has got higher magnitude. It is quite common sense. This is if theta is what? Less than 90 degrees. Okay. Now come to other cases. This all you are right. See, in the class I will explain. If you want very systematically, you have to see the notes only for that one. See, now consider important case. Consider the case. I forgot one thing. When theta is less than 90 degrees, when you find alpha 1 or alpha 2, you will get both positive. So, therefore, no confusion. Both will get positive means how you marked result will be in the same direction. So, this I will explain once again. It can never come negative because I will tell the reason it later. Now consider the case of theta more than 90 degrees but less than 180 degrees. See, if theta is 90 degrees, it is a simple case. If theta is 180 degrees, you do not require law of parallelogram of forces. Why? Difference of the two forces will give the answer. This all I told earlier. Then that is, see here, that is, I will take one force here, P1. Don't bother horizontal vertical, P1. Other force, P2. See correctly here, P2. Passing to point O. I will take one more case. Point O, say once again P1. This is P2. This is your theta. Now, very important, you should not take this theta. Why? Because, see, when the two forces are going this way, see, 1 minute now, I will show the resultant here. See, I show the resultant, P1 here, P2 here, O, here also. I do not know which force is more, which force is lesser. That I will explain later. P2, P1. See, when you construct the parallelogram forces, what will happen? See here, this force will come this way, this will come this way, complete the parallelogram, this is the resultant. Here also, same way, resultant. This is for both the sketches. Therefore, resultant, see, it may be near to P1, near to P2, but anything, randomly I am putting resultant R. Here also depends. What? If P1 is more than P2, resultant will be near to P1. If P2 is more than P1, resultant will be near to P2. That is, it will shift this side. Now, very important, see, this is angle alpha 1. This is angle alpha 2. Here. Direction, see correctly, don't by heart clockwise, anti-clockwise. From the force P1, alpha 1, do not by heart clockwise, anti-clockwise, alpha 2. Now what happens is, here, this is the angle theta. Theta is less than 180. I will tell it later. If theta is more than 180, never apply law of parallelogram forces for that one as it is, because it will give wrong concept. See, I will tell you it later. Suppose one force here, other force is here. Some will tell, sir, this theta is more than 180 degrees. No, cancel it. Take this theta. So that resultant will go this way. See, to draw parallelogram, you can't draw this side. You have to draw this side now. So remember, therefore, one important, never and never consider theta more than 180 degrees. By chance, in a sketch, see, for example, in a sketch, a question given, 60 Newton, they will tell here, 80 Newton. They will deliberately tell you this way, this angle is 200 degrees. Find the resultant. If you take theta this way, you may mark resultant this way. Wrong. See, resultant will be this way now. If you want to draw parallelogram forces, how to draw? See here. Okay, it should come here. Okay. See, for this, okay, I will explain here. Even if they give this 200 degrees here, when you draw parallelogram forces, see here, 60. 80 to some scale. I am just telling 80 randomly, 80 Newton. Now, how you can draw parallelogram here? Now see. This is the resultant. So, what you have to do is, this is the angle theta you have to take. So, that theta will be equal to, if this is 200 degrees, undoubtedly it is 160 degrees. This I should not explain for somebody who is studying engineering. If this is 200 degrees, why this is 160 degrees? If I explain, someone will tell, you better not teach. Why? This is beyond the level. Some dignity required. See, some minimum requirements are there for those who are learning. So 160 degrees. So therefore, make a big note now. A big note. I will tell you now. When you apply law of parallelogram forces, see, if it is less than 90, no problem. If it is more than 90, okay. See, you can turn whatever way you want, no problem. See, this way, resultant will pass this way. If it is outgoing force, if it is incoming force, resultant will come this way. Okay, that is no problem. Now, if the theta is, see, by chance, I have turned the hand now. I think my hand I have difficulty because what to do? I can't turn. If the theta is more than 180 degrees given here, don't take that theta. Take this theta or make a big note. Your theta for calculation purpose should be any value from 0 to 180 degrees. In case theta is, they give other side angle. If the angle given between the two forces from other side more than 180 degrees, do not consider resultant on that side, consider resultant on that side where theta is less than 180 degrees. See, otherwise what will happen? You may mark resultant this way. No, see, this way, resultant this way. So make a firm note how the force are outgoing, same way resultant, or how the force is incoming, same way resultant. Make a big note. Furthermore, in the class I can't tell. See, I told you, for your information, just outside the subject now, another 1 week time, I am starting sending the notes for those who register it. I will make a separate class. I am telling because people will understand the importance of the notes. Because each and everything what I tell here will be there in words with examples and sketches. Okay, now leave it now. So remember now before I go to next part now, one firm decision. We will never consider theta more than 180 degrees. Make a firm note. Okay. Make a firm note. Okay. Now discuss the cases. Now I'll tell you what happened. See correctly what? Concept. Now see, very important concept. It is not for time pass. I told subject I am teaching complete mechanics, strength of materials and structural analysis. In the same way I will teach. And remember, those brain teasers also I will give answer. There are more than hundreds. I will give answer one by one because I told knowledge, let it spread. See, now, I will start fresh now. Start fresh. But one warning. Warning. Now I should not tell. Warning. 100% sure that theta is never more than 180 degrees. This is guaranteed. Now don't ask me once again. Anyway, you can't ask. So, if it is more than 180, take other side angle. Okay, over. Now see, I will write here. Let P1 and P2 be the two forces. Be the two concurrent forces. Concurrent forces passing through a point O. Through a point O. Point O. Point, say O. Okay, need not be always O. Say O. Okay, but say means say O. Let theta be angle between them. Between them. Next, see. Let R be magnitude of, 1 minute now, I told you 100% guarantee that your theta is not more than 180 degrees. This I told. Now, sometime in the offline class, someone will ask, sir, if they give more than 180, I will tell, leave the class. You did not hear what I told earlier? Oh, sorry, sir. Someone will tell, hey, he told no, if it is more than 180, take other side angle. Okay, okay. How many times I have to tell it? See, there is a limit for patience. People should understand this one. This is not high rocket science to understand. Okay. Let R be the magnitude of resultant force. Resultant force. Remember, make a note. Resultant force, 1 minute, before that one. Let alpha 1 be angle made by resultant, I will put R only, resultant R to save time. Resultant R with the force P1, with the force P1 or alpha 2 be angle made by resultant R with the force P2. With the force P2. As shown. As shown. Now, little later I will tell you. As shown. Okay, now. See, remember now, two cases are there. Before going to as shown right here, note. Theta can be, how is your theta? Your theta can be less than 90 degrees or your theta can be more than 90 degrees, but a little bigger I put here. See, I will put here two important cases. See, note, theta can be, I put that way, you write that way, theta can be less than 90 degrees, write this way, you write here, or it is possible that your theta is more than 90 degrees but less than 180 degrees. Means, see, any one P1, other P2. Any one P1, other P2. Okay. Now, I will write here now. Irrespective of, this is my special word. When I want to stress something, actually, IRR, that's all. See, you are right. irrespective of. But I will write sometime in the class, irrespective of. Someone will tell which English, not English. Sometimes you tell little, that way. Irrespective is to stress the point, just for fun. Irrespective of whether theta is less than 90 degrees or theta is more than 90 degrees and or less than 180 degrees. Remember, more than 180 it will never come. If it is exact 180, there is no theorem required. If it is exact 90, direct case. When inclined is between them only triangle degrees. Remember, I will write here, r equal to square root of p1 square plus bracket not required p2 square plus 2p1 p2 bracket is not there into cos theta. Okay, no bracket. Why? p1 square plus p2 square plus 2p1 p2 into cos theta. And alpha 1, you write here, I should not tell, angle made by resultant R with the force P1 equal to tan inverse of, I told so many times, other force P2 into sin theta divided by that force with which you are referring, P1 plus P2 into cos theta, or alpha 2, that is angle made by resultant, made by R, why waste space, made by resultant R with the force P2, with the force P2 equal to tan inverse of, we are referring with the force P2, numerator, other force P1 into sin theta divided by P2 plus P1 into cos theta. This is the result. This is valid for whether theta is less than 90 or more than 90. More than 90 up to 180. Above 180 problem. Decide anyway, now onwards in the class, you never bother more than 180. Okay. Because if it is more than 180, parallelogram will come on other side. Okay. See, the pen cap dropped because protesting. How many times you are telling it? See, maybe it is telling me, don't tell again and again. Okay, now this much over. See, everything over? Okay. Now, be very careful. Now, be alert. Red color. Be alert. Alpha, when you find alpha means what? Either alpha 1 or alpha 2, anyone. Better write the answer with sign. Here only with sign. When you go later for resolution, I will tell you no sign. I will be careful. I will tell the reason here with sign. Now, positive sign indicates, you write here, first of all make a note. You make one more note here. Positive or negative sign has nothing to do with clockwise, anti-clockwise. Don't by heart clockwise positive, anti-clockwise negative. No. What is the principle? Positive sign indicates that direction considered in sketch, one sketch you are writing, in sketch is correct. Therefore, what to do? Therefore, what? Mark angle alpha in same direction. in same direction, remember, same direction. Or right here, if you consider clockwise, answer comes plus. Yes, correct, it is clockwise. Or if you consider anti-clockwise, answer comes plus, means what? Yes, correct, it is anti-clockwise. So don't by heart. Clockwise positive. See here, one sketch is gone now. Okay, sketch, where is the sketch now? I removed the sketch. Or I have not shown the sketch, I think. Actually, sketch is known for you. Okay, let us sketch later. Okay, this is positive sign is no problem. Okay, now, one note. If theta is less than 90 degrees, there is no chance of getting negative sign for answer, for alpha. Alpha means alpha 2. Why reason, tell me? Because, write the reason here. Because any sine of any angle, sine of theta, if less than 90 degrees, is always positive. Cos of theta, if less than 90 degrees, is also positive. Positive. Therefore, there is absolutely no chance of getting negative sign. Therefore, you will, because, why? Because sine theta and cos theta both are positive for theta less than 90 degrees. Therefore, when you finally write the answer, you should write, I am dictating, what direction you considered alpha 1 or what direction you considered alpha 2, mark it in the same way. Don't by heart clockwise, anti-clockwise. So, theta less than 90 is fully cleared. Now consider the case when theta is more than 90. See here, what happens? More than 90, but guaranteed less than how much? 180 degrees. That is guaranteed. Okay, now I will do one thing now. This I will remove now. Okay. This is very, very important, remember. Especially objective questions. Now consider the case when your theta is more than 90 degrees, but of course less than 180. Someone will ask, sir, why less? I will tell, my class is not suitable for you. How many times I have to tell you? More than 180 we don't consider. Okay, sir, sorry. Okay. Then remember. Then, see, right here, for any angle more than 90 degrees but less than 180 degrees, sine theta, sine of the angle theta is guaranteed positive. You should know it. Sine theta, 0 to 90, both sine and cos are positive. Above 90 up to 180, sine is still positive. Y means trigonometry. But cos theta will be negative. You don't have to write it. When you use the calculator, it will take negative. You remember it, negative. Therefore, see, cos theta can be negative. See here. Here, see now. P2 sin theta. Therefore, in the expression for both alpha 1 and alpha 2, numerator will be 100% positive. Why? Sin theta is there. But what about denominator? Right here. What about denominator? In in denominator, see, one force term is there, one force into cos is there. One term is purely force. Other term is force into cos theta, and summation is there. Furthermore simplified, is it not high school students? One term is here, P1 is a force, other is force into cos, force into cos. Now, sign for denominator depends on whether that force term is more, force alone term is more, or what? Whether force term is more, numerically, force term is numerically more. Numerical, no sign, numerically more, or other term, that is force into cos theta is numerically more. Numerically, I am telling. Numerically more. Okay, now I'll conclude this one. First of all, this much explanation is not required. Simple language, show the, again I forgot here. Okay, see, I rub this one now. Now see, I write here now. See correctly. If numerical value of force term alone is more, then denominator will also be positive. I'll give example. See, numerator guaranteed positive. Denominator something plus something. See, numerical, this is for example 20. This is minus something 18. I told numerically, see, numerically 20, when theta is more than 90, the second term is guaranteed negative. Why? Cos is negative. Now, positive, negative. Positive is higher, numerically higher. So this also is positive. Therefore, we will get positive sign for alpha. Alpha means alpha 1 or alpha 2. Therefore, very happy. Why very happy? Because no confusion. Confusion comes when negative sign comes. No confusion. Hope it is crystal clear. See, in the notes I will split with 3-4 examples there. See, this is numerator is always positive. Denominator, two terms are there. See, now, if this numerical value 20, this total minus 18, then 20 is more. This is also positive. High school level mathematics. So therefore, no confusion. Okay, now, concluding part, I write here. Everything you write one after other one. But, Kannada language. But means Kannada we call adare. But if force term, if numerical value of force term alone is lesser, and numerical value of force into cos theta is more, that is example, see, alpha. Tan inverse of. numerator 100% positive. Denominator, this is 30 minus of, see, 30 plus here, see, plus minus 45. Oh, therefore, this will be negative. More. Then, denominator will be negative. Therefore, tan alpha, see, either alpha 1 or alpha 2, tan alpha, when we substitute, will be negative. Then, what it means and what to do. I am there to sacrifice, to know everything here. Then what it means and what to do. That I will write some full board here. 1 minute. I will remove everything. I am now explaining the case. See, when you are about to press tan inverse, display is negative. Now I will explain with the full board. Wait 1 minute. Because I have to write neatly the board. Very powerful concept. Okay, now start. I am going to write in different color. The important concept, not black and red. Red is for resultant. See, I will use green color to highlight it. What it means and also what to do if we get negative sign for alpha, either alpha 1 or alpha 2. Before you go further, first remember, before you proceed further, first remember, when we use calculator, and when you take inverse, when you consider tan inverse, we will never get angle more than 90 degrees. Actually 90 also will not come because tan 90 is infinity. Okay, leave it. You will never get more than 90 degrees. First remember. In any calculator, I think throughout the world, it always gives angle less than 90 degrees. It will never give more than 90 degrees. There is a reason for that one. Leave it, mathematics. 90 degrees. And in calculator, sometimes when we consider tan inverse, or when we perform tan inverse of something, that alpha is red color, because why? It is a result. That alpha, again I am telling, alpha means alpha 1 or alpha 2. Don't bother about it. Alpha. That alpha, that alpha will come in display either with positive sign or negative sign. Actually, positive sign, it won't tell plus, understood. Unsigned is positive. Sometime negative will come. See now. If positive, happy. Already over. Happy, why? No confusion. But if negative, see what it means and what to do if you get negative sign for alpha. So, option 1 I will tell you. I will give option 1. Option 1 will be, mark that angle alpha angle alpha. Again I told alpha 1 or alpha 2, alpha in a direction opposite to direction considered in sketch. That means it can be either alpha 1 or alpha 2. In case you mark clockwise, negative comes, mark anti-clockwise. Or in case you consider anti-clockwise, negative comes, mark clockwise. Or what direction you consider, mark in a direction opposite to the direction considered in the sketch. One option. How? Some will ask, sir, how? Wait. Examples coming up. Examples thoroughly coming up. Wait for some time. Don't be in a hurry. Remember this one. When I solve examples, I will tell you. That class I will tell. If you have not gone through the previous class, class 6, do not come to this class, I will tell. I will tell at that time. I will announce there. You are not fit to learn from me. You are not serious. My education is not meant for you. If you are that much lazy and you think you know everything and skip that class, now you get confusion. It is your problem, not my problem. Correctly go through that class, then come I will tell. How? Don't worry. Okay, now I will tell option 2. You see, I will tell option 2. See, option 1 is okay. Now this is okay. Option 2. I think this is best option. No confusion. Best option. Both are okay. I prefer this is the best one. Best option. I will explain both. Best option. First of all, note tan 180 plus alpha, see, any angle, alpha, theta or gamma, beta, anything, tan 180 plus alpha is also equal to tan alpha. You should know that one. First remember, tan 180 plus alpha is tan alpha. Why means mathematics. First quadrant, all are positive. Second quadrant, sine positive. Third quadrant, tan positive. Fourth quadrant, cos positive. Okay, that all I am not bothered. You should know this you require in the chapter principal stresses in strength of materials. I will explain at that time. Tan 180 plus alpha is tan alpha. Therefore, if you get alpha with the negative sign, what to do is, then see, I use this color. Add 180 degrees to that alpha value displayed in calculator. And write that alpha equal to minus whatever you got, comma, or you can tell one more thing. Either write that value. This is whatever you got, question mark. Whatever you got, or plus another value. That is what? That minus whatever you got plus 180. I will tell here. Suppose you get alpha, one value, minus 10 degrees in the calculator. Then write alpha equal to minus 10 degrees or minus 10 plus 180 becomes plus 170 degrees. Actually 10 will not come, plus 170 degrees. Plus, it is plus actually, plus 170. And use that second value with the positive sign for marking angle, for marking alpha in sketch. 1 minute now. Let me see the display there in the camera. Okay, visible. Or I will tell one more example here. Actually not required. See, it's already over. That is, use this value. Or lastly, see, suppose, note, alpha comes in calculator, some higher value, minus 80 degrees, decimal will come, then write alpha equal to minus 80 or minus 80, see, minus 80 plus 180 is plus 100 or plus 100 degrees, and use this. How? Wait for some time. Examples are coming up. Exclusive example. I will take 4 problems there. Not 4, I think 3 problems sufficient. One first problem, angle more than 180. Angle more than 90, less than 180. Alpha 1, alpha 2, both will come positive. Some will tell, sir, good, okay, over. Second round. Once I will see that alpha 1 comes negative, then one more question, when alpha 2 comes negative. I will consider both of them. And then I will tell, in future, you have to remember. So class number 5, this is class number 6, I think, 6, and coming up 7 are critical. Now, I decided not to go for very lengthy classes. Usually class of around up to 1 hour only I will take. Except when requirement is there. Sometimes I may be forced to take a class of higher duration. Like even sometime a class can go up to 3 hours also. If emergency is there, if a lengthy example is there. Otherwise, I decided upload more classes, small duration, because nobody want to go through class of 1.5 hour, 2 hour like that. Okay. I decided almost daily upload the classes. Spare that much time to improve your knowledge. Now, lastly, I will tell one more thing. For those who really go through entire class, I doubt very much. So many have no patience. These are all simple way I am explaining for understanding for students or those who are learning. One who is learning, he has got limitations. You should not thrust too much on him. See that he learns in a simple way. Therefore, I always take simple way, because some may comment, instead of this way, you can tell technically some other way. I will tell, come, I will tell you technically. Let me see whether you understand or not. Technically, I can talk. This is all simple procedure. That's always what I am. Explain in a simple way to make everything clear. Then those who want will improve their knowledge. Let them come up in the life in structural engineering. Then we will talk technically. If someone comes to me later, tell, sir, I am technically very sound, everything understood. Shall we talk technically? Yes, we will talk technically. Okay, if at all someone will do that way. Therefore, don't bother about such comments if it comes simple way. Too simple is telling, yes, too simple only is important. Okay, now I will wind up this class. I first thought, today I will cover problems. Then I decided, no, better first give complete idea about that one, so that when I go to numericals, examples further, see, earlier case I took less than 90. When I go to more than 90 now, within 180, I will explain at that time, but I will tell this class is important. If you are not gone through previous class, I will tell you better not continue this class. That much responsibility for you. Okay, thank you. See you in the next class with more examples.